cool. Just setting up. Turn off the mic for now. Okay, I think I got everything. Let's see. Today we're gonna embed a Lisp inside Haskell. We did it also. We started working on this on Friday, but we basically got stuck debugging the HEDN library, which threw an exception for some reason. After a bit of debugging, we found out it was because it used monad fill. So like, monad has a function in its interface which is called fill, and you shouldn't use that. But some libraries decide, well, like sometimes you kind of need to fill, and it happened to be used in that case, which ended up throwing an exception. But we fixed that. So now we actually need to do the important part of the Lisp builder, which is, well, basically making it run, right? So we got the parser from the library, and now we need to parse user input and make it basically go. So yeah, that's the, I guess, fun step. And we're gonna do that today. So this thing is actually running in a browser, right? So we get a user input, and that user input will be Lisp expression, and that's what we're evaluating. Yeah, I think it's like kind of interesting. Let's go start working on it. So yeah, off stream I did a bunch of stuff. Like for example, I added some types here, and I started like trying to implement the actual thing, and I haven't finished yet. But I got like a long way to get something workable. This is me experimenting with the right, like, because we're building it in Haskell, we have to deal with types as well. Because Haskell is strongly typed, whereas Lisp is, you know, not typed at all. So we need to gain back types, and the parser kind of helps us with, you know, providing us with primitives. But we also need to make this work with Haskell, these primitives. So like we need to do pattern matching and then figure out what to do. So we have like a bunch of logic just for dealing with that here. This is the expression we're actually building. This function thing allows us to express functions in like Lisp style and then make them available from out Haskell. So we like have the environment, right? In Lisp you get like an environment thing, SDNF, that's this one. And we can provide functions in there, which is this. So now in Lisp you can use multiply. So we can write expressions like star 4 5, right? This will evaluate to 20. At least that's what I'm expecting. At the moment it won't, because we can only do doubles. So I just did this part, and that's like a to do. And we need to do this because otherwise you can't figure out the type. Like all this stuff is polymorphic type variables, and if I would use a star directly, it doesn't know what type this x and y is. It needs to figure out what type it is because it needs to prove to itself it's correct. Okay. Cool. That's that part. So like this is how we make functions available in our language, by just providing this environment thing. And we use the expression to have a thing we can evaluate with. This is like the mapping between Lisp to Haskell. And we either have a function, or we have something that's fully evaluated in normal form, or we have an error. That's basically what we can get. And the errors are the ones defined here. Runtime error. So this could be because we are expecting some type and we don't have that type. Or it could be because we didn't find whatever value we needed. Or it's like not a primitive. So yeah, it's just like dealing with the language, I guess. Right, I guess that's like the introduction, and we can just continue working on this. What I could also do is like show where it's being used. Let's quickly do that. I don't know if this compiles. I don't think so. No, probably not. Huh? Let's make it compile first then. Not scope, module E. Right. Not a scope value. Okay. Oh, right. It's called val instead of E here. Let's rename it. Build. Yes. This will also be kind of annoying to fold over. We can't fold because it's not a foldable. We want to fold basically. You wanna pattern match on this thing, on function, and then apply whatever value you have from your args list, and then check out the next one, which also may be a function or a normal form. Yeah, so let's see if we can, well, we probably just write a recursive function for this. Oh my god. So what do I want to do? I want to apply this arg list function. Apply expr. We'll have like some list of values we want to apply, right? And this will return also an expression. Like this is the final result, the normal form. Or maybe like another function, that's fine. Yeah, so like what you want to do. Okay. I'm thinking how to implement this. In the case of empty, I guess you just return x. You're done, right? You don't have any more to apply. So like, if it's an error or if it's successful, that's fine. In case if we have a single value, so that's like arc, and then you know if you have a function, we know what to do. Oh, I know. Okay. Like we'll do this. We'll better match on that function thing. Funf. If your function, will apply the function arc and then apply expression remainder. Run. Oh, it's the wrong way around. Right. So like if this is like a single one and the rest of the list is empty, we'll go to this branch and we just return itself. If we match some fun, we'll do that. And in any other case, we'll do. Well, if we're normal form and we have arguments, we say that we try to apply even though we couldn't. And if we have error, then yeah, it's error. And error is pretty obvious. I guess like in the case of error, we just want to return it. Maybe we want to accumulate errors though. Like we're losing the value of error. No, I think like if the other expression already was an error, we're just like returning that error. Like we're not the cause at this point. Error. So we can just return that. So we can ignore the lists, and if your error E, we'll just return the error. Excellent. Like the other thing we could have done is like accumulate another error saying that like, okay, you're trying to apply a function to an error and that's like not allowed. This is the function and this is like the argument list, but no, I think we can just forget that. And then finally, if you're in normal form, but with some value, but you still want to apply arguments, that's an error as well. So in this case, we'll just say too many arcs. I'll put in a list of arcs. That's like error, too many arcs. What if we have too few? Can we? Right, like that's the other case, right? If because we always need to have one value in this case. But what if you have a function without any arcs anymore, but we still have the function? So that will be the empty case. That's like too few arcs. Can't really return the like we can't return a function. Well, we can return a function, but we can't really say anything about it. I think the music stopped. Hello everyone. Oh, it's just too few arcs. Now, I don't know what to return for. Like what else to give it? Because if we return a function, then yeah, you don't really know what it is. Okay, excellent. So now we know how to apply an expression with a list of values. Let's use it. Let's use it in eval or in apply, I guess. Apply expression, apply. Now, like another thing is these functions don't have access to the environment. That's also pretty bad, actually. They should have. But if you want to do, for example, like variable definitions, you need to have access to the environment as well. Make a reader out of it. But yeah, this is version 0.1. We can only multiply with doubles. Oh, phantom types are like not used at all, right? They're only for type checking. And this thing, they're actually pulling in the value of, like they're using it to get a value back into the program with the type class as resolution. So like, I mean, I guess you could also call it a phantom type. I just thought phantom types were only for type check, I don't know. Symbol. Oh, you don't know about E symbol. You want to know about list as well. You want to know about symbol. So this should do something, I guess. You don't know about lens. Oops. The type argument that doesn't appear on the right side. Oh! Okay, yeah, then I guess this is a phantom type. Or they're using it, right? I guess it doesn't appear in the definition on the right side. But what's up, Sky Bro? Are you sleeping, man? Another phantom. Sleeping. Sleeping with power-ups. Snoozing, perhaps. E-value with expression. What's going on here? We're making Lisp in Haskell. So this is actually for my little input thing. User can make like a Lisp expression, and then, you know, we need to make it go back into usable Haskell code. So we need to do some typable hacking, for example. And then, you know, we can bind our like symbols to functions like this. And then, you know, the Haskell function will be multi because we need to actually know what type is there. But this will only work for doubles like this. But yeah, we got it. That's pretty interesting, I guess. Probably one of the more... It's better than debugging. Let me put it like that. Considering how much I debug on stream. Let's see. You want to have an expression. Wait, what? Couldn't match the value with expression. Okay. So here we have another case of we need to figure out what is inside here. Case of success, huh? We'll make like a with normal function. It will make out of an expression a validation. This thing will just unpack an expression. If it's not in a normal form, then it will give an error. Pump up the volume, he says. There you go. What's up, people? Doesn't become louder for me, so it's kind of weird. Yeah, so like we'll just better match on that, I guess. Maybe we should make prisms. Maybe I should make prisms. I thought it before. Maybe we should make prisms for all the value stuff. By the way, Google gave me 24-line Haskell programming, including parser for minimal Lisp. Yeah, but I bet he's not using EHCN, right? And if we have error, we basically will error. We'll just put it in error case. And for normal form, we're success. Right, so we can do with normal. And this will put it into the list, or the validation thing. And finally, you're not success. You need to be success if you're a list. Apply list. We manage the empty case. What if we don't have a symbol in front? What do we do then? Calling apply and we don't have a symbol in whatever we're doing. Oh, that's this case, I guess. It's just a list. Okay, yeah. That seems correct. So now we're done. No, we're not done. Match type. E-value. List of value with value. Right, we need to become a list again. Strip tags. Oh no, I think the issue is that it's not tagged at all, so we need to add tags to that list. Maybe we can strip later. So, does anyone know what the tag thing does? I'm curious. We can make a tag. Check the spec. And they're tagged. Like my tagged. You can support extensibility through a simple mechanism. Hashtag, followed immediately by a symbol starting with the alphabetic character that indicates that symbol is a tag. The tag indicates a semantic interpretation of the following element. It is envisioned that the reader implementation will allow clients to register handlers for specific tags. Upon encountering a tag, the reader will... So, what's a reader? Does it explain? No, does it explain? Upon encountering a tag, the reader will first read the next element, which may itself be a compromise of other tagged elements, and pass the result to the corresponding handler for further interpretation. And the result handler will be the data yield tag plus element. In other words, reading a tag and tagged element yields one value. This value is the value to be returned to the program and is not further interpreted as EDN data by the reader. Tag samples without a prefix reserved by EDN for built-in defined use system. User text must contain a prefix component. A parser basically turns a string into a data structure. So yeah, we use the library for that, I guess. I still don't really get what I get out of it. For semantic, reading implementation will allow clients to register handlers for specific tags. Maybe it's like a macro system or something? You can add handlers, but what is a handler? Is it a function that can just do something? Maya person. It allows extensible types. Okay. So, like, my other question is it safe for me to just ignore that stuff? Because that's what I'm doing right now. Who knows? It is tagged. No instance is list. Oh, I need to do e-list. Right. Song request. Okay, thanks. Oh, we should probably make like a bot command for this. We can just make a gist-based page. Or maybe integrate with the YouTube API. Oh, that'd be amazing. No, I hate the YouTube API. Add it to the playlist and it will encounter at some point. Maybe play it now. I will look it up now. Excellent. The inst. Records. Oh, you don't have brackets in core as well. You just desugar that to functions. That's what I mean. You don't have brackets in core. Actually come in handy stuff. But like, then you mentioned the generic stuff, and I was like, yeah, but you know, we have the generic stuff, so you could say Haskell has it. Yes, sure. You're right about that, I think. I think we need to silence. I can't handle the vocals. I'm sorry. Oh, and data, but may actually can handle stuff. Oh yeah. The data is a bit of a problem at the moment. I'm not sure how I do type errors. Well, like I figured it out with Casper, I guess. This is the first part, and the second part is mapping. Map. It's so ugly. To think of it, we can just put a function in here. Is that true? I think so. Yes. That's with the proxy. So like it just figures out the first A, I guess. I don't know how that works. Oh, that's because this gets... Actually, that we're looking at the wrong thing. This expression function isn't this at all. This is a lie. This is a lie. It's a dirty lie. It's actually this. So it's like a expression. Really? So yeah, like there's a difference between EDN and closure. That's really weird that they make differences between that. How much is redundant? 42. Like what? How is this redundant? Oh, if the list is empty, we'll return X anyway. Just need to be above that. Define but not used E. 44. Oh, we have the arcs. Too many arcs, and we also have a normal form, I guess. We'll also return that then. Like this. Find but not use primap. Really? I used it, right? 43. Ramp shadows. Okay. You can be ramp prime then. Are you thinking nothing is used? But that's fair because we didn't use. Let's see, the actual function eval. So we can use that. There you go. So we have decode EDN, which gets a text value out, and then we use the monad instance of validation, which we added at some point, to put it into eval. The only thing we need to do is make sure to strip the tags. EDN reader and closure actually can read things with more than 64 bits. Yeah, so closure is not using the spec apparently. That's kind of interesting. So, but like they made EDN. That's why I missed it. But like they made EDN for closure, right? It's that entire thing is just built for closure. So why don't they change the spec then? I don't. Well, the other thing is like, why didn't they just make a spec that's implementation defined? Can reasonably parse and apply logical reasoning without any out-of-band documentation. Yeah, I don't have that issue at all at the moment. Like, if my system, if a message like is incorrect, I will just reload. So at the moment, what the issue is that this thing is expecting Lisp errors, but we made eval return a nominality list of runtime errors. So we need to map this. We need to map this runtime error to Lisp errors, and we have to run a thing for that. I'm not sure if this is being used, so let's try make it like this. No, it is being used in translation. Okay, yeah, that's fine. Oh, that's fine. We'll just use a bifunctor again. I guess we need to go over first. And then we need to apply function run inside it. So this is like, first is a function from data.bifunctor, and this is a bifunctor because we have one thing we can map over and another thing we can map over. Oh, the first thing we can map over is then the failure condition, right? Which is runtime error in case of eval, I guess. What we're doing then is wrapping that failure condition. We also have mapping inside there, which is the non-empty list, and we're wrapping it with the run function. This is a function that takes a runtime error and returns a Lisp error. And then it will be the same type as the Lisp error. And then everything works. Except the language, of course. I also need to fix that. Runtime error, not scope. Right, because we renamed it to run. Lisp error run. Excellent. Ambiguous type variable text 0. What? Code text 127 in response. Oh, you don't know what type of the tag is. Right. So because we stripped the text before it's like defined anywhere at all, it doesn't know what this tag ever will be. This is like a similar error I had before. So yeah, the solution will be not to do bimap. Just use first, I guess. And then provide the alias text value, which will pin down that type. And then we'll compose this with tags. Because it like can figure out the value of this tag now, because of this thing, we can safely strip it. Just like a little bit later. You can't figure out that EDN value has a HTML value. Right. So we'll just... I thought we already did this. Huh. We did this, right? Maybe not. Maybe we need to import a type class or something. Yeah. Oh, it's text value. That's the issue. Why is it red? But this thing allows our little data input thing to figure out how to render EDN. And we just use the standard function for that. Cast prime. Oh right, we're not using this. So now we should be able to actually do the function. I wonder what will happen. Type of from module data input redundant 21. Input of widget data input is redundant 8. Oh, this is a spec. So it's EDN spec, right? Should multiply code EDN. So what we got here is this code EDN. This is like decode and eval, right? Validation. OMT. Lisp errors. Value. So I'm like moving this into a separate function so that I can unit test it. Again, we don't need to do this anymore. Oh, we do, because I also want to unit test that, I guess. But this is decode and eval, and we're expecting this to be, should be success. No tag. Alright, we don't have a tag, huh? We'll have float. Floating 15. 18. Right, we have a double sign as well. But it doesn't eval. List tagged nothing. Oh, it's already in a list. But like if we have a list with no elements inside it, we're just returning the list. No. If you have a list with no elements inside it, we should evaluate it. Because we're putting a list around it as well. What if we do this? That works. Okay, cool. Still, like, we should be able to do this. We should be able to do this, I think. Well, should we? What do you think, chat? Should be able to do this. What do you think, chat? What do you guys think? I'll make a test for it, I guess. So what if we like put another layer in here? Like, what if we say this is legal? And then if we put another layer in here. Does this evaluate? This will be 9 times 5 is 45. Should multiply nested. Should multiply Lisp. Should multiply naked. So I can see what fails. So naked is also failing. Why? Another primitive. Right! We didn't do this. We didn't do the 3 part. Yeah, there's a lot wrong in my language. I think this should evaluate to itself. I think it should. Like, you can have redundant parentheses in my opinion. Yeah, you can. So what if you have... What are you saying about it then? You're not giving me an error either. Like, if I'm in list... Like, if I'm a list, I'm evaluating you. List with variables. You're applying the environment, stripping tags, variables. If the list is empty, we'll return an empty list. Okay, excellent. Apply expressions args. The expression is function of that. Right, the thing I'm expecting is always a symbol in case of lang. Lisp error. Found parse. X. What is parsing? I'm just translating as reading. I don't know what to say parse in Dutch. Not parsable, huh? We still have a couple of type errors. Maybe we don't want to do this then. There should be an error as well. Then it should be the error. I guess the naked one should also be an error. This is not possible. Yeah, syntax error. Excellent. So this should also be an error, but it should be something else. Like we're trying to make a list apply. But the curious thing is you can do this, I think, right? No, you can't do this. How do you make a list then? So you, like, list always means application, huh? Quote. But if you do quote, would it be represented as how? It's not EDN. Quote delays evaluation, but it's not valid EDN at all. How about that? But that's like another closure thing, I guess. Long form. Quote's built in, not found. Symbol quote. Yeah. So it's a built-in function, I guess. We can make that as a function. Trivial. It's identity, right? Special form. It's not a function. Well, this is an error from myself. It's not. This is a runtime error. This is what I inserted. Let's change the rules of evaluation. Right, that's what you're getting at. Okay. Yeah, but like I'm making the rules for evaluation, right? So we can decide maybe later to add quote. But not now. Let's just say this is expected quote. I'm just like recording what is and what isn't expected from, like, you know, people who are used to closure, I guess. Because sorry, I didn't read. So the idea of reflect and reify are what you run into here. By default, you reify the one level of evaluation so you can reflect back one level to quote it. In principle, you can use that stuff to enable multi-stage programming. Yeah, not just compile and runtime, but rather arbitrary end levels. Okay. I don't know. Okay, excellent. Compiles. We should format it as well. So ugly. Oh wow. We should add, like, now we have a reasonable spec for our language, right? We can do nested expressions here, like this thing and that thing. And we also can do top level expressions like this. We are able to do these two things I think I'll add the ability to do external information. So we'll make like a reader environment out of this. The function we're trying to build is actually like, so that's like roster entry. The list of roster entries needs to be in here somewhere. And then we also want to add like maybe username, or maybe the entire user. So yeah, that should also be available. I'm not sure how they will read it though, but probably like it will be available as a map. That's a good idea probably. Yeah. And then we just give the capability to query maps. We can use keywords for that, for example. So that's like another thing for the apply thing, right? We can check if there's a keyword in the first position, and if that's the case, then we can also, you know, check the second position if there's like a map, or vice versa, and make that work. That's a good idea. Yeah, but we still don't have the test working because we need to do the nested stuff as well. So this is to do nested, huh? And then the other thing is should feel nested without symbol. Wait, that's success? Right, we're not detecting for that condition yet. Right, like if we get a list, then we just return it at the moment. But that's wrong. We should fail on it. Like if there's not a symbol, we should fail. Yeah. Failure, not a function. The first, like I was looking, what is this? Can we hide it? Yes, because it's the environment. That's fine. Not a function. Should do nested. What is it saying? Failure, not a primitive. Right, this is failing on primitive. We can fix it later. Let's first fix this. Oh, it's returning no tag instead of tagged. Blah blah blah. So yeah, we can use no tag instead. Oh, that's actually e.no tag. Yes, exactly. No tag. List, no tag, expected, no tag floating, no tag. I don't see the difference. Got list, no tag, list, no tag. Oh, the symbol also needs a no tag. You got it right? Oh, Chud. Hi, Chud. Sorry, I didn't see you in chat. DJ, where? Project Lisp on GHCJS. Yes, that's correct. We're doing GHCJS with this project, the roster project, and like having a bunch of compilers running in the background to regularly make it work. So I'm building like a little Lisp to allow users to calculate wages, basically. And we got multiplication kind of working, but now I'm trying to make it more, also do like nested stuff and also remain like proper error reporting with this stuff. Positions are just tuples, dude, inside time. How do I get it out? So we'll just pattern match, I guess. And then, you know, if there's one error, we'll return that. We can't return multiple errors, unfortunately. Maybe we'll make the error branch from expression also a non-empty list. What to think of it? Maybe that expression is a bit like, maybe I shouldn't make the errors intrusive and just use validation instead. I'm not sure. What do you guys think? This just looks a bit weird to me. What it before, like putting the error inside your data type. Use validation instead. Because now I need to juggle between the two, right? Can't easily use apply. I'm not sure. I'm not sure. DR is basically the templating engine. Obviously implementation detail was. So what if we remove this error branch and we'll make validation everywhere here. Validation non-empty. Non-empty and then runtime error, right? Yeah. Oh my god, it's beautiful. You know, we're expecting this function to do the same thing. Oh my god, it's so beautiful. In fact, it's so beautiful that I'm considering making a valid expression type edit. This thing also will return valid expressions. No, this will return expressions because we're always sure that it exists. Yeah. Valid expression. Oh, everything breaks, huh? Yeah. everything breaks. For one, we can't do this. We need to do failure pure. Because we need to be on list. But the nice thing about this setup is now we can have multiple runtime errors. We can collect them. We probably won't do it ever, but we can. We have the capability to. Which is good. If you're an error, then you're an... Oh, you're never an error. Okay, so this is apply expression, right? So like the thing I'm looking at is now the pattern matchings are invalid. So this should all be like success and then function. Or we should like make this just not handle it all with errors. We'll just make expressions out of this. But it should still be able to return if it's invalid or not. Because we also had error cases before. So now we don't have that issue where we need to pattern match on errors. Like we can't apply errors, that's crazy. That's nice. I'm not sure if this will work, by the way. Like if we do it like this. Well, it works so far. We have a function from... A function is an expression to an expression, right? Or value to expression. Yeah. Well, maybe this should be a valid expression, though. 36. Match type maybe with validation. What's the difference between type maybe, record type valid expression, actual type maybe valid expression? Oh, we're getting rid of maybe by doing this. What are you talking about? How is that different? You're lying to me. This is the same. Oh no, we're applying it to the entire thing. Okay. That is completely different. I agree. But I do want to get my bind back. Oh, we don't have undo. Fine. We do have what? What is this? What? I'll just copy it again. And like keep on undoing things. Get my bind back. Yank till that. Delete till that. Yank till that. Paste. Delete till that. Should make a macro. Oh well. Match type e tag text value with value tags. We have envs. We have tags. EDN list. Right, so we need to get rid of the tags. Huh? Will be strip tags. Strip tag. Okay. Put a match type validation non-empty runtime error. Expression with expression in mind. Oh, look at that. Right, so you need to be a valid expression and then you're done. Right, you also need to be on success, you need to be success. What's this part? Put a match type expression with validation non-empty expression. 69. Right, I wanted to mention this. You should be a valid expression. So this allows us to fail. The function should be able to fail because we don't know the types we're getting. And we used to have that as part of the expression, but we moved that out to keep everything consistent. 68. Match type expression with validation non-empty. Wait, what? No, maybe this doesn't need to be that because they're still expressions. They're not evaluated yet. Oh, the function inside here needs to be like that. Okay. I see. Yeah, that makes sense because we'll just do bind to get the next expression out. Okay, yeah, that makes sense. So like we're doing a check to make sure that everything is successful at each step. But to do that, we need to, make sure that it knows that this list of functions is successful. So yeah, prime map. Wow. You should have it though, prime map. Yeah, you're returning a valid expression. Put it match type. Need a valid expression to valid expression with validation and expression. Oh, you're missing the map. You're missing the environment. So this is where you would validation on empty with them 4. Like I'm passing this prime map thing, the standard environment, because I need to be able to resolve list as well. This is no longer prime map. This is something else. It's almost like bind. Think of it. Like one step in the program. Eval step. Yeah. This is like a case where the function grew later because I just wanted to implement multiplication right at first. And then I'm just like making it bigger to also do nested multiplication in this case. Or should rename it though. I don't know to what. What do you think? What do you guys think? Oh. I wanted to go there. And close the other thing. This is where it's being used. Data input field displayed comment. Let's actually no longer do that and actually do it on the display because I want to see it on the page itself. Reflex on. So now we can actually see the result we're doing easily without having to use the inspector. That's a bit better. What I want to do is give this dynamic. But what I want to do, we need to be able to add the standard environment to the decode and eval function. Well, I guess like it's already eval. Let's make a convenience function. Let's see. But the reason we want to make this configurable is because we need to add something. We need to add some dynamic things, I mean. Like, for example, we need to be able to the entries. This will be a symbol in the environment. And this will probably actually be literally a something just decoded to HCN. Just a map, for example. That'll be a good idea. And then we'll just make the ability to access the fields in there. So do like keyboard lookups. Yeah, that makes it a lot easier. And then we'll just provide some functions to traverse and whatever and do folds, I guess. Wanna do this? Maybe we'll make it simpler first and we just provide the time. And it's worked. We'll calculate it for them. And then they can like make a pretty printer out of it. Yeah, we'll just do that, I think. Because like having the time available as like a week and then as a month should be enough to do a lot of things already. Yeah, and then you can also, yeah, we could do like week time and month time. Month time. We'll just make a, let's see, expression out of this, right? It's a normal form. So that will be this one. And we can just wrap it directly into, well, right now table. Just be directly a value week. Maybe we can even make an instance. Like I don't know if it implements generic from EDN to EDN. Minimal definition to EDN. Any list, any set, any vector, and only tuples of 4. don't know about bigger tuples. I don't think they have a generic implementation, unfortunately. But that's fine. We'll do it like this and just provide that function, right? Maybe also make a data SDN settings. Week. Exactly. Just fix it. The typical fixed point solution, right? Let's type char expression to char expression to text expression with actual type char expression star function. Let's put this line by line and see if I'm missing another one. I think I have it. Fun, pass, fun, prime map, SD, prime map, cross prime, mult prime, 85. Are you asking more of me? I have a value as well. Huh? I have a value. What about fun? You're valid. Okay. Oh, I know. $2. 2 big bucks. Couldn't match expected type. Right, that's the end. Like that doesn't work anymore. You actually need to have a map of. Well, you need to have settings basically. This is like a nice Haskell API for setting the standard environment of this like Lisp DSL thing. And that's also why we made lenses, because it's like the Haskell part. It needs to be nice. I couldn't match type blah. Wait, I think this is correct. Or is it 146? Right, now you're actually missing the settings. Luckily for us, we can provide a default for now. Well, maybe we want to make this work immediately. I think that's fair. But yeah, let's do that. Let's let the client figure it out. For instance, for 2 EDN minutes worked. That's a good point. We'll make that. To EDN, huh? We'll implement to EDN fee. The value. It's trivial to do. So what we get is the A, and we need to make a value out of it. Actually, for like contravariants, type classes are pretty good. Floating though. Policy floating. To EDN minutes. 16, huh? You want to know about floating as well. Match type double with int. Right, it's not. It's an integer. Right, because we're minutes. What am I talking about? The minutes worked will always be represented as an integer inside the EN thing. We don't know how to go from EDN. We just know how to do 2. We don't want to know because we want to get a text out. We're just going to display whatever. Let's use to figure out how to make a text. SDN settings. Right, so this is the thing we need to fill up. What's interesting though is we can use the dynamic input we made last time. I think like 2 weeks ago we made an input that could handle dynamic values or dynamic validation. And this is what we need right now, exactly what we need right now, because it isn't a dynamic, actually. Yeah, that was just a useless argument, basically. Like we're doing that by type class, so why would you, right? Maybe it was the ability to override it? No, you shouldn't override it anyway. I don't know why I would. Yeah, that's actually kind of nicer. I will bring my like average down of arguments I'm using. Okay, cool. Data input, right? Data input EN settings. This is the one we're trying to fix. First of all, this should be empty string here, and then like this, and then the value we're starting with, right? Which is nothing. Maybe like constant. We're trying to get out of here anyway. Right, so we're trying to get. We need to provide an initial one. Oh no, we can do nothing. Right. Constant nothing. Right, so like if we don't have anything to give it, then we can just say nothing. So let's see. We need to provide the initial value, which is like displayed to the user, and then like this thing is the actual value, which is getting printed. So this thing will, as soon as this thing updates, will be overridden. But in our case, we're not going to do anything like that because we don't have this at all. Yeah. So then the input settings, right, which is dynamic, which is why we're using that function, because this is the only one that has a dynamic one. So to do that, we want to get these like dynamics, these dynamic times. This is our minutes works, I think. All minutes work, yeah, they are. It's like minutes work for the month, and the other one's minutes work for the day. So we want to have both of these. Worked month, worked week. Yeah. This week and this same thing. No, it's not. Week. So like ampersand is the opposite, right? It's the opposite way of. The ampersand one is doing it in reverse of dollar. But I like money, so we'll use dollar. Yeah, month. This is month. Excellent. So what we can do now is then use. It's worked here. Oh, worked month. We'll just write it the old-fashioned way. Excellent. It's an event? Wait, I didn't even know if I had a text event. Oh, there's an event. That's annoying. Why is the event? So this thing apparently only updates by event entries. This week. Where's this week? What are you talking about? How do you get that stuff? Entries dying. Where's this week then? Go to select the day, Entries dying. Filter cell day. Okay, it's just doing some. Okay. I think it's a pure function. I was looking if it makes an event out of it. I don't want that, I think. Oh, maybe it's because it's inside the model? It looks like an event to me. It says it is. Let's see what the compiler says later. It's fine. This is the other one, right? We'll do the same trick. But do week instead of... Oh, this is a dine. Only month is work. So why is month different? Because it's using entries. But you can use entries dine, that's fine. Let's make a dine out of it. I mean, I like the fact that I have that, but I don't need it. Let's not do it then. Keep everything consistent. Using dynamics everywhere. Like the nice thing about dynamics is that they combine with each other. So I can hit with the floating value. So yeah, now the two tests fail because it's giving a weird ass type error. That's not right at all. It doesn't right thing. You're expecting right. You're actually this is the primap type error because it figures out the type by using this double function. However, we can use alternatives. I think primap. Let's try doing that. Not I. Yeah, probably validation does know about alternative. So this will become one block. Oh, it's so beautiful. It is so beautiful. Like I bet Lumi loves this stuff. Look how beautiful it is. But these things bunch of trade-offs. Either you accept the possibility of rounding, assuming some level of precision, and having a normalization scheme, or you should widen the eventually ended up with doubles. For most user-facing applications, I personally don't like doubles because it's not really worth in actually if performance doesn't matter. You don't know about alternative, huh? Seems strange. Yeah, I'm not sure about like the doubles and integers. I think I should be able to support this because it will be like a pain in the ass to explain to people why this doesn't work. I think it should just work somehow, and I'm expecting a precision of two decimal points basically. That's about it. I think complex. Haskell has a ratio type, and I think complex as well. But the one I just showed, that's precise. We could use that. But the problem is EDN doesn't support that. Like EDN will make well, like we could probably cast it to ratio or something. But you will still lose the precision, like initially, because it's from EDN like that. Should make a competing spec. Fix EDN. The other thing I was thinking it should do it like this, yeah. Or just make like. Not like the fact. Well, EDN is extensible. Yeah, I guess you're right. We already have an integer type, so we can just like make everything integer. Like the thing is, we need to change the parser. That's a problem. Yeah, but that's the thing, right? Like I'm not gonna write the code. The user will write the code. So we'll see. I think having a precision of only 2 or 3 decimal places is fine to use floating points like this. We'll just round everything after that. Just round everything up. Every multiplication will round. It'll be beautiful. Like the way you should see this language I'm building is not as an actual language, but more like just a ripoff of PHP. It's running in JavaScript for God's sake. What are you expecting? Precision? We don't have alternative for validation, unfortunately. I don't know why. But maybe it's like mono plus instead. No, it wouldn't be mono. Why aren't you either is alternative, right? Is it? Maybe it doesn't have a empty for the issue. Go to either. Applicative. You don't have alternative either. You are applicative. What? You're a semi-group. You are a semi-group. Why would I need alternative if I... Well, what is alt? What? What does alt do? What the fuck is this? If extended... Honey? This is... Oh, this is the better one, I guess. Like, this is without... What? By the way, it's best practice to not use vectors and maps as functions unless you are using them in a higher order function. Rather you use them the other way around. Generic interface. How would you use them the other way around? That's an example of a higher order function, I presume. This is a set ABC, and you test if it's part of the set. You're filtering out stuff, right? One failure. 3 failures. Wait, what? Acting floating 50. Right, you can't do that stuff. Right, that's what I'm trying to fix. Semi-groupoids. Did we fix the integer one then? Integer multiplication, cross multiplication. So we're not even doing integer multiplication. Alt doesn't work. So to clarify, you write key rather than file guide. But you can't do that for factors, right? I just tried that. This doesn't work. It needs to be the other way around. Maybe I flip? You use get for factors. Oh, there's a function. Neil doesn't know about it. Maybe I did it the wrong way around. Way around, okay. Like I would like say it would figure it out, right? Because you know I can just figure it out. How about this? We'll put you into X, and then we'll make like the paragraph. It should be lower than that then. Should be pushed down by the closure strictly backwards compatible. Many of the things you find are not recommended anymore, but they won't ever get removed. Like, it's a great way like to sell the language, I guess, if you're structurally backwards compatible. You know, your old stuff will keep on using. But you know, you'll accrue a lot of stuff as well over time. Like, because you make mistakes. I bet this thing was kind of a mistake then, I guess. Or something. Integer multiplication. Language is designed in such a way that you can always write libraries to fix mistakes. You can literally override everything or stays backward. Okay. I guess it's like what a lot of companies do. They'll have like their own custom core, fix all the things. That's nice. It's like a custom prelude. It's how I no longer support integer division at all in my entire program. Because I have a prelude. There is no way to get a divide by 0 exception anymore. I fixed it. Impossible now. I like this level of hacking. And what I'm getting from you is that you can even go much farther in closure than this. It's about control. You are in control. So why is my thing not working? I thought I had alt. Maybe alt doesn't work how I expect it to. So if mult D fails, then we go into mult I, right? What do you do for alt? If you're failure X, try doing X. If you're success A, try doing A. That's exactly what I'm expecting. Why is it failing though? I noticed that to sneak it into enterprises, the whole closure is actually just designed as a Java library. And it's much easier to sneak it in a Java library than to switch languages, you know. Wait, what? Like, would you get like a quasi-quoter and just have like, you know, just like a Java class file, and then you just start, you know, eval, and then you put in a whole bunch of closure code. How would you even get a past code review? I guess it's like cooler to do that stuff with closure. Yeah, like, because if you want to have a dynamic system like that, trivial to do. It's trivial, don't worry about it. We do it like every day. Lose for breakfast. Just still serialize functions over network. Don't worry about it. Put a match type validation on empty runtime error expression. Right, you need to be like this. It makes total sense, by the way. Don't worry about it. No instance for typeable. Right, we need to specify the typeableness, both of the types. And whenever you see typeable in Haskell, by the way, you probably should scratch your head, because it means that someone is doing runtime type checks. And if you like Stormy type languages, this is like a big no-no. But in this case, this is the only thing we can do, because we have a dynamic system. We need to check. 5 failures. How about that? So this, like, everything is broken now. That's what I'm getting from this. Technically, the one thing that serializable func does is keep track of the dependency hierarchy of that func for other funcs, but it transmits them as well. You need to have a namespace then as well, right? You need to send your environment, this thing. Kind of neat, because if you build like a Lisp like this with Haskell, you get very clearly visible what is necessary to run a closure, because you know you need to make the types work. And I knew for a fact that you needed an environment to just put in functions and whatever. Stuff is a bit harder to do. Really fun though is having a continuation in a function and then stop it in the middle and send it over the network and have it continue. Yeah, but you could also do that with just an environment, right? It's basically the backup state. Oh no, you also need to have an execution going on, I guess. Partial execution and track that. But you can just like track whatever is being applied with Why is everything broken? It doesn't like bimap prime, I think. Bimap prime. think I have a speech impediment. By map prime map with by prime map. Excellent. Oh, local variables. Right, I forgot about that. I don't have those. I don't have those. I don't think you can even make lambdas in this language. Moment. No, you can't do anything. It's really simple. I don't think this thing is even Turing complete at all, because you can't store anything. Not that I need it. I don't need it to be Turing complete. That's fine. You don't care about that. It's a dumb property anyway. Who cares? Why are you failing? So what if we just do mod D? Maybe that works. Oh fuck! Don't give me the warning bullshit. I don't want to fix those. Like it doesn't run unit tests without. Let's look for the options DHC. Yeah, let's take you. Put it in here. Just ignore them, okay? 5 failures. Okay, so it's definitely because my by prime map function sucks. Technically, Clojure has no local variables in the service language, it's just immutable bindings. Oh, like I do. My awesome Clojure in Haskell in JavaScript implementation. It's gonna conquer the world, I think. I've already got it ported to 3 different platforms. No, wait, like, no, I'm running it on JavaScript, so I have it ported to like everything. Ah, pretty portable. I wanted to refresh, but it's not gonna help me, huh? So apparently my by prime map function is broken. I'm not sure why. This thing will return a valid expression. Why do I need to cast this? Cast it as well. Oh, I'm casting twice. That's the problem. Like, let's make it return just an expression. Why wrap variable name in parents? Because we need to do lookup. It's from the std_env. Oh, maybe we can do it without? I don't think so though. You don't know about it, huh? What are you saying? Type error, expecting validation on empty runtime error expression. Yeah, we need to do a lookup. I think I can add breaks as well, right? What is this called? Roster. Yeah, maybe we should also make it like it should be able to look that up directly. I don't know. Yeah, probably. I don't know. Like we can support both, I guess. We'll add another test for that then. So many tests. Minutes. Oh, no. It's like week worked. Right? Week time. We should call it week minutes. Month minutes. Month's work minutes. The other thing I was thinking about is that maybe I should also add translation for this. So have this available in both English as well as Dutch. Week work minute. Zero, huh? In Clojure we generally use the add symbol syntax to deref something that's lazily computed, which expands to deref variable. Add syntax. Not a primitive, it says. So yeah, we could say that we also want to look that up if we encountered that prime map. I think that's a fair question to ask. You can just use eval on that. This is a valid expression, right? Yeah. Runtime error expression. You can just use eval, I guess. I guess like all the other cases should be just eval. No, like the other thing you want to do is you want to eval it and then try putting it in it again. You may end up in a loop if you do that, actually. Could this end up in a loop? I'm trying to apply it. It would either like run into an error or... I love how disgusting this module looks. So much shit going on. Valid expression. 55. We just got a value though. We'll probably call eval then in that case. And it will give me a valid expression out of it. Try using for the primitive map. Yeah, I think that makes sense. I don't know about the add thing though. What do I want to do? I want to have symbol. Yeah. This one even. I'm gonna call it eval with that. I have e-value, huh? Yeah, we have that. We have sim. And then getting the env, the f. If you have no arcs. It depends on what you call them. There are also functors, monads. Functionary implements a lot of stuff. In fact, like the functor as a categorical object is more persistent than functions. Well, maybe not actually. Or maybe, I don't know. Like the reason I'm saying that is because like function error implements a functor. So all function error, like all functions in Haskell at least are functors. But you also have functors that are not functions. So you have like more. Anyway, like veering off the question. Process, if you can make it, you should probably just get it resolved. Yeah, I'm doing that. I was trying to do that. Do arbitrary values, yeah. But it doesn't compile. My eval doesn't work. Valid expression, huh? Yeah, that's fine. And then we're gonna use that valid expression in primap. Oh, it's giving me an expression back instead of a value. So we actually need to do another step, which is to do like with value, with normal. I'll just like lazily compose this, I guess. I'll be lazy. Be lazy. Go. Oh, God damn it! Really? Do this first. Oh no, you're not. What am I doing? Guess you like this then. Normal. Oh, you're getting a value. But regardless, you can make it. Should you probably just right? You should have plus resolved plus function which then gets applied to. Or we should resolve to the value of the variable and not. I'm doing this. I'm doing exactly this. What you're telling here. I'm looking up the star. Like that's the only one we have right now, right? And so like I'm looking up this thing, this star, and then just mapping it to Haskell functions with the values. But like the thing I was building here is like looking up without parentheses, so symbols that are defined like with plain. If you have like for example 4 times minutes, to do this instead of that. I think you should be able to do this because we know about keywords already, so we can just do this. And that's like this little line, but I can't get the thing to compile. Can't get it to compile. Maybe we should do stop doing it point free. Probably. Was I looking at the wrong line? Yeah, I was. This actually worked. What the hell? Cool. 59. What? 59. Oh, you have a list, right? We can just apply them. 1 for 2. But make sure that they all have Lisp errors instead of runtime errors. And then we use fish to make them chain together. Like it's this pattern part. Like this is the monad part, and then thing we get as input will be first sent to the code EDN, which returns a text value, and then that text value gets sent to eval. However, this doesn't want to have text, so we first strip the text, and then we can use it in eval, which is just a normal value, and then we get a valid expression out of that. And with the value expression, we go to with normal to create, instead of an expression, we create a value. So like we get an expression and return a value. And these two phases are just to fix up the errors of both of them, to make them like Lisp errors. So yeah, we can use fishes. Beautiful fishes. So what do we add now? We added the ability to do this. That's a bit easier to use now. Let me think. What do we want to do next? I think we can add like simple addition and removal. It's kind of like boilerplate. Yeah, I need to pin types like this. I wish I had like a better way of doing that. Making like some kind of age list or whatever. Or too hard to do. So yeah, we can make another function. We want to have division as well. Sure. Division is kind of interesting because we have a maybe value in there. And I don't think maybe is represented into EDN at all. Is it? Well, maybe they can do that. Oh, they have. From EDN A, maybe A. What will you do then? I guess you just use nil. Oh, excellent. 2 EDN, I guess. From EDN. We have 2 EDN. Yeah, they will use nil. Okay, good. Makes it a lot easier to implement division as well, because you can just cast We'll do melt with div. Okay, so melt will be div. And we add a division. Fractional. Right, we need to do the other thing. We need to do not... Like the backend functions can be different for this. So we can do, I think it's like remainder or something into division. I have no idea. We have the prelude though. It's a prelude. So quote remainder. Oh, I guess it's div. Integral, huh? Now we also have division. And we also catch the maybe values with nil if it happens. Let's actually test that out. We can actually make a spec for that as well, I guess. Yeah, let's actually do that. It's a bit faster to test like this. Handle divide by 0. So this is like 2 and then 0 should be nil. It's still successful, but it's nil. It doesn't like it, huh? Maybe other things are also broken. So let's just try a bunch of things. Divide 5 by 2. Got 0, I guess. This should be floating 2.5. They're both failing. How interesting. Like, can I get rid of this entire typable thing? I'm not sure if I can. Casting Y? Pattern matching on the value, and then we're casting Y to be like F, I guess. But it may fail, and then you get a type error. Oh, right. The issue is that the Y is every time different. We can't really figure this out at compile time, so we need to do it at runtime. Therefore, we need to have typable. Okay, cool. Okay, let's see. Oh, let's do format then. Yes. Format text. I need to be able to... What do we have for formatting? I'm actually not using that at all. I'm just like making my own stuff every time. Haskell formatting. Combinator based type safe formatting. Yeah, I don't want that. I want to have like a printf, not type safe. And the reason for this is because I don't want to... Yeah, like this seems reasonable to me. Printf type. That's a problem. I just need to have it... God. This is in base. Printf type. If printf is implemented intentionally not visible from this module, if you attempt to pass an argument of this type, it's not an instant. Okay. Maybe it's like in data text, printf. Because this thing is like accepting a string, and we don't want that. So, like, it's already slow enough. I took a text format package. No response from other 2 years. See other answers. Oh. Formatting, huh? 11 months ago. Ah, I thought he was like a big name in Haskell world. Oh, I looked at this one before, but like I can't do this. I need to have a crappy one. Or the text libraries have been supported. Another question. Can it be pure? Oh, I know. Maybe data text implements that text. Huh? Probably implement that function. Yeah, type class. Type class for is string. Printf type. Okay, what? I can build my own. I don't want to build more stuff. I want to use other people's stuff. I want to have cheap code. Here's printf. It's actually interesting because it uses the var args. I use text.printf in base myself. Not sure what the problem is. It's not a string. F text. Oh, because fold arg can do Stack Overflow, I guess. That's what you mean. Yeah, I should write about that. I bet it will be... Well, people are running into that, right? So, you know. Fold R explained. Let's actually Google it. See how popular. No, that's not what I mean. I would like. I bet if you find something, you do space leak. But the issue is that if you're a beginner, you don't know about this word at all. You would Google for this. Oh, there's actually a wiki about it. It actually explains it, but in a lot of words. Book about evaluation. Do printf. No instance for print type text arising from the use of printf. Probably need to back it again. Excellent. So now I can just jam it in. Yeah, this is it. So the problem was that he was used to inferior languages. Exactly. He just had an inferiority complex. No, he was saying that he had trouble with laziness. But then, you know, once you start reading the blog post, it turns out the issue he had was basically a massive space leak. And I was just thinking, like, okay, that would be probably a good opportunity to write about or something. Space leaks are scary in Haskell. They hit you in the blind spot. And you know, if people say they complain about laziness then, and they actually complaining about space leaks, then fair point. It is a problem. I wonder if it's just like static analysis tool for space leaks. No, there you have it. How does this work? GHC plugin providing non-invasive auto-instrumentation of Haskell projects for dynamic strictness parallelism control. This will soon include optimization for automated space leaks. I believe using minimal strictation. It's still in development, they say. Wonder. Could email him. The thing is that not intuitive from a syntactic point of view. It requires you to actually reason throughout the evaluation semantics, which is almost none of the other languages actually do. Evaluation semantics that makes it hard to learn for beginners. But I had like no problem at all with it. Like they told me it was lazy, and you know, keeping that thing in mind and reading your code, and what will be the problem? I thought like when the blog post started talking about space leaks, I had suddenly had like an epiphany and thinking like, oh, this is what people are talking about. Because yes, they are scary. He wasn't even mentioning the fact that it was a space leak. He was just saying that it was like due to laziness, which is true, but it has a name. Strict evaluation semantics are just more natural to people because they're analytical world. No, you think lazy. What the hell, man? Like, have you never heard of people, you know, making judgments without, like, for example, the don't judge the book by its cover? That's because people are lazy in the way they think. Yes, like, people are lazy. Literally. And there's a reason for this, because if you're lazy, then you conserve energy. And if if you were living in the time of Hunter and Garrett, the people that were lazy and were conserving energy when they didn't need to do anything, get like a survivability increase. Why? I put in a float, huh? But you want to have a text. Okay, maybe we want to do that then. How would he do that float? How it works. So we can't put in floats at the moment. That's a problem. That's not one definition of the term. Basically it refers to going back to personal basic associations which have been established at childhood or biology. Yeah, that's what I'm saying. This guy doesn't know what he's talking about. That's what I'm getting from reading this text. Massive overgeneralization here. Also, you know, massive pop culture based reference. Catchy phrase. No references. Oh, yes, references. No, these are footnotes. These are not references. You're referencing Wikipedia, that's bad. Referencing Aristotle, that's a bit better. You need to put references here. Called a bit dense though, or sparse though. Basically, it refers to going back to personal basic associations which have been established at childhood by the brains. Okay. How do I put a number in here then? Can I do that? Can I do like double? We need to pin all these types down. And it may even like, does this throw an exception by the way if it goes wrong? What if you are learning a concept that is novel and cannot understood easily as an obvious analogy to use something? So, no, you need to learn it from first principle, which is an unconscious process. See, like when I started doing, oh, closure wouldn't really apply. Okay. Like as you get older, it just gets more hard to do that stuff, I guess. Does this thing throw an exception? Is this a partial function? That's a big no-no, by the way. I can't have that. No partials. Are you partial? Not fine. Will have a natural tendency not to find an optimum, rather a sufficient first good approximation. Yeah, it's called no, it's satisficing. It's called satisficing in game theory, and it models like human behavior. Developed by psychologists. Good enough. This is one of the things I want to implement. Well, I can't really. Well, I can. I can do that also for rock paper scissors, I guess. And this is like lowering your expectation over time, for example, if you don't get any rewards, or increasing your expectations if you keep on getting rewards. Yeah, but like if I have the analogy, right? You know, I have the word, so I have the power. No need to explain anything. Yeah. What will happen if I fuck this up? Oh. What if I do like 2? Would you get mad at me? Error call. Uncalled exception. So we're not gonna use printf because it's partial. I'm not gonna use printf because it's partial and we can't use partial functions. I'm not gonna do that. I'm not gonna deal with that. So we actually wanna have something else then. I don't like this one. I need to have it in string. And I need you to return maybe. Or like, you know, monad fill. Be a monad fill. Damn it. Do I need to make my own? So annoying. Let's see. So the internal function of by prime map can be error? Question mark? Prime map can. No, you wanna actually cast it, huh? Maybe we'll make this by prime map prime that does the casting stuff as well. Because I just want to get a valid expression out, basically. I want to have this more flexible. Oh, I know. We'll just make the more flexible one. Fine. That returns the expression. So, yeah. And then we'll do std x, y, and then to by f, we'll append this stuff. Prepend, I mean. Yeah, excellent. So now you just run this function c, and then we're making a value out of it, this e value, and then we're putting it into normal form to make it an expression, and then finally we'll put it into success to make it a valid expression, and then it fits this type, like this function will fit this type, valid expression. So yeah, this one is more powerful. There's no c. I guess we need to do that trick again. This is like attaching this function to the second argument, like putting it to the result instead of. This is visually alert, you could do that. Oh, well, I guess not. Yeah, okay, it's gonna be annoying to do. Excellent, it compiles. Compiles. Okay, now we can. Let's first delete these. We'll make variations later once we get this to work. We can't use printf because it's broken. Broken as fuck. We can use format either though. You're gonna return a validation. Or maybe an either. Yeah, you can return an either. We'll just keep the same type as this. I'm not sure why they put the errors in strings. So strange, like they're completely aware of text, but apparently errors need to be strings. Format either. So we need to have the format, which is a text x. So this needs to become a string because it's expecting an is string, which is a string. Oh right, we actually need to make it into format as well. So we need to do from string, and then you'll become a format. And then the second argument, y. Yeah. Int f text y. Oh, it's fine. We'll just do this. We need to get rid of either as well. So we're probably gonna use prime in this case. And like do the entire validation stuff ourselves. Because we already get a text out or we get an error out. So we wanna bimap. This thing. For the left branch, we want to make into probably a runtime error. Yeah, I don't know. Lisp types, huh? String, I guess. This is like a function error. We don't really know what it is. Where's play map? So the left one, we will make a function error out of that. And the right one will... So we need to make that into a proper text, which we call string. Like, I mean, we need to make a value out of it. Like this thing needs to become the value we have in expression. We have a value now, and then we need to put it into normal form because we want to have an expression out as a result. And then finally we need to convert that entire either thing into, I don't know what I had here before. I think we need to make a text out of it first. So it's like e.value. Right, and now we need to build up from value, we need to go to normal form. And then non-empty station type. Text either non-empty runtime error expression. So that's almost what we want, except we need to make this a validation, which I tried to do with that view thing. So let's do that again. Let's try using the ISO. Shouldn't be too hard, right? It's an ISO. Could possibly go wrong. View. Now it just gives up. View. How? Why? Validate, huh? How the fuck do we use ISOs? Tell me. What is from? There's like a specialized module for ISOs. Full lens ISO. This thing is like just a change between itself. An ISO. Twice. Okay. Completely useless. I love none though. I love that I found it. This allows you to unwrap maybes. If they're equal at least. Oh! I forgot about this. Good that I like to look at it again. So this thing just takes a predicate. Like if you're true, then we'll convert you from maybe. So you get like a default and a predicate. What the fuck? I thought you could just throw an ISO into a view and it will work. Let's look at this. Like if you're an ISO, you're both a lens as well as a prism. Like this is a very strong relationship to be. Almost nothing is this. Except new types. All new types are this. And either and validation happen to be also like this. So what this thing means is that you can transfer between two things. And once you change between them, you don't lose any information. So you can always go back. At least like in, you know, broad timers. So I thought like, okay, let's just use lens stuff to view stuff, right? Lens and then you can just view it. View together. Not just losing any information, but necessarily the same representation, right? Or it's also the same representation. What do you mean by representation? Maybe it's preview then. I'm just guessing at this point. Oh, you didn't like that. Validate. Provide just a function. I doubt it though. Like he wouldn't do that. You should be able to use lens stuff. I just don't know how. Well, there's the ISO thing, right? You can use that to expose the constructors. It's actually how I started using it first. I used to use wrapping, so that's like the hashtag thing. This review, I believe. And I used viewing to go back. So then my question is, what's back and what's forth, right? The way I understand usually how this works is this is the thing you're going to. So we need to use either instead of validation. I'm gonna go back. I felt like validation. I'm just trying stuff. This is dumb. Mostly applies to structures that represent equal information with different structures, e.g. a binary tree that is balanced versus one that isn't. I'm guessing... So... does not have strong identity constraints. It depends like how you can very accurately detect silences. So that will be good. And also like keep the music playing. But yeah, I'm gonna go. Maybe we'll rate someone as well. We'll rate someone as well. Quickly see if anyone's online. Oh, Tim, but that is online. Let's rate him. So see you guys tomorrow. Tim Baudet.